Test. 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 Un, deux. Un, deux. Okay. So I think we can start. Of course, everything is recorded, so if you are not able to watch it, it's no big deal. Can you hear me? Let's first check. Oh, there is no response. Oh, yeah, it's because of the delay then. Great. So yeah, Dark Forest is today indeed, and it's right here. It's magnificent and it worked great, and yeah, but it will be at the end of the video, because we are going to do some other stuff. So yeah, we will do that first. I can just copy my code if you really want it in Discord. I mean, don't care, but I would prefer that you wait for the full explanation maybe. So yeah, I posted in Discord already. Or maybe if you want, you can join in public voice in Monkeys. Guessing it's okay also. So today is about biomes. So yesterday we talked about basically how a biome work, and we said that actually biome are using what we call a QLCG, so a quadratic LCG, and they use it on the 64-bit period. So biomes are the only stuff in Minecraft that use the full 64 bits of the seed, and basically because of that they have well, better entropy than most of the stuff, and it's needed because biomes are like the building block of Minecraft. If you don't have biomes, then you have issue because, well, the terrain and feature depend heavily on the biomes. So that's the change they made in 1.16. They made everything in the biome. Basically, the structure are added because of the biome, and it's easier also to maintain. But it was always like that. Just in 1.16, it's a bit nicer to read. Okay. Yeah, we can say QLCG or QCG. Actually, the two are valid if you look up Captain. But yeah, it's a QCG if you want. Yeah, doesn't really matter. Yeah, that's saving. So, biomes. Biomes are using what we call layers. So there are multiple layers that are stacked together. And because they are stacked together, they made what we call the biome stack. I mean, there is not much term, like it's depending of the precision of the people. So I call that biome stack. In fact, there is multiple biome stack, and if we represent that, basically it's, so we take a pencil, and there is a biome stack, another biome stack, another biome stack, another biome layer, biome layer, biome layer, biome layer, and each time the output of the first layer is given as an input of the second layer, and so on. So it just, yeah, it can be done recursively, but it can be done iteratively. Doesn't really matter. It just that it's a feed type. You start a first layer, then you give it to second layer, and so on. And of course, because it will be simple if it was already only that, each time you are going up a layer or down a layer, you're actually changing the scale. So at the beginning, the map look like that. So that would be at layer 1. But if you go at layer 2, then the map is already divided in 2 each time. Well, here it's in 4. Yeah, but you get it. So we get a lot more actually, and each time it's refined, and because it's refined, at some point we come to simple blocks, and that's great because actually that means that if you have something here at the beginning, then it will affect all those chunk and block here. Oh. Maybe I can need to mute you. Yeah. And because if there is something here, it affects everything. That goes for recursively for everything. We can attack the biome layer at different stage. So we can say that if we attack at the first layer, then it will propagate through the whole stack. So I think, well, it's basic introduction, but today stream will be decomposed in a few stuff. So the first part will be so yeah, we saw the biome generation introduction, which was quite rough. Then we are going to biome generation, actually the algorithm behind. Then we will go in biome generation example, well, how it looks actually, to understand better the algorithm. So we'll do step 2 and step 3 at the same time. And then we will go for biome shortcut, which is actually what I talk. If we affect one layer, then it will propagate through the other layer. And that I will explain why actually it happened, because it might not be intuitive at first glance. So yeah, that's today's program. Guessing it will be about 1 hour. Of course, everything is recorded, so you can watch it afterwards. I mean, it might not be the best explanation, but it's the best I can do without preparation, and we are doing a proper video about it. Of course, I made a video last year, but yeah, it wasn't very clear, and it was quite simple. So to view a bit, maybe I should hide that because it will distract you. You can see a lot of stuff, and you can see nothing. So we'll be using biomes because it's in Java, so it will be easy to understand for most of the people. Of course, we could use a biome, or we could use the REST implementation. And for viewing, we will be using a mind map. So it's made by Captain Wutax, and it's basically a mist, but in better. So you can just state a seed. So yeah, for fuck's sake, 42, and we say the number of thread, and we just started, and we got one map. It's a bit faster than a mist, but yeah, a bit. Yeah, it's faster than a mist. It can be improved with GPU, for example. But yeah, we will see a lot about it, because actually there is some interesting stuff. Notably, you can see overlayer, and that's quite interesting because you can see in depth how it goes. But we will explain that later, because else we will lose everyone. So the repository of biometals, yeah, it's a bit messy because there is a lot of stuff here. Hi everybody, I saw a lot of people are joining. Right. So what we will be interested today is the source biome, and it will be overworld, because the neither and the end biome will be only using simplex noise, and that's not what we are looking for. And basically, because it's using simplex noise, it's only using the 48 bits of the seed, not the 64 bits. So we'll only look for overworld. Then we don't care about noise. We'll go through the layer because that's the interesting part, and device will be at the end to explain the shortcut. So the source, because that's actually the interesting part. So if you look like that, you don't understand a lot of stuff. But actually, in the biome generation, there is multiple stacks, and that's because of the history of Minecraft. So if I take something like that and do new, there is actually a first stack which does most of the stuff, like setting the continent layers, the water, and so on. So you will have a continent and the water around it. Then there is a divergence, and there is a river stack, and there is the variant biome, which are basically the new biome that were added since 1.6, 1.8. Let's say 1.8 because it's easier, but 1.6 was actually the changing point, I think. The variant, then they are joined together, so the river and the variant are joined together, and they are made into one layer. And this layer, you added since 1.13 the ocean, so it's only variant of ocean, and that's done with simplex noise. So again, it's bad. No, but it only uses 48 bits, so for a given ocean, it will look the same for 2 to the power 16 seeds. And that's merged again to produce the final layer. And because the final layer it's at scale 4, it's actually scaled down to scale 1 thanks to what we call the Voronoi zone. But actually, yeah, it's Voronoi because it's an algorithm behind, but it's actually quite simple to understand what it does. Okay, so that's the schema, the diagram, but it's not clear like so, so let me pull something, because actually there is a better one. So if you go to Biome, because yeah, that's oldest maintained repo, then you go in docs, and there is what we call the layer summary, so let's just get that one. So if you look, it's exactly what I said. So there is a first stack which does every legacy biome. So it does the island, then it removes some ocean to make sure that there is actually some land, because else there is too much ocean. It adds some biome which are depending of temperatures, and then it adds mushroom and the deep ocean, which was the last one that were in 1.6. Yeah, not sure about that. Then there is a new biome which are added through the biome layer, which is quite important nowadays. And then it's refined and it's merged again with some noise layer. So actually river init is a noise source, and it's merged in the hills, and then it's refined again with the smooth scaling and so on. And in the other side we have the river, which is using a noise and also the first stack, and it's merged in river mix to the Voronoi. So that's why till 1.12, and in 1.13 there was the ocean stack, which was added just after the river mix inside the last layer before Voronoi. So that's it. That's the structure of what the biome stack look like. Actually, it's multiple one. And if you look at the code, it's actually pretty much the same, because we try to depict it as much as possible, as close to what it should like. So the first part is the base, so the first stack. So it go from scaling 4000 to scaling 256. Then there is a new biome chain which is added and is correctly scaled with the edge made. And afterwards there is the noise layer, which is made, and this noise layer, depending on the version of course, is merged inside the hill and is making the variant. And in the variant we are adding the new biome, so new biome. Sunflower plain was added. So sunflower plain was added, but also all the mutation of the biome, so the hills, the extremes, mutated, and so on. Everything is added here, and it's smooth scale. And then there is a river chain, which is declared here. It uses, of course, a noise layer, because that's important to have some kind of noise to start off, else you are just repeating the same step. And then you are mixing everything. You are making the river around the chunk, the biome borders, to make sure that actually it looks great. And you are merging everything. So here you are merging the variant and the river. And if the version is above 1.13, you are making the ocean stack, which is actually, if you look a bit in it, it's actually a Pelon noise. Well, it's not actually Pelon noise. It's a Pelon noise too. It's a noise layer, and basically because of that, it's only using the 48 bits. Then it's scale and it's applied to the full layer. So it's merged with the full layer. And then again we are using the Voronoi layer to make sure that we go from scale 4 to scale 1. So instead of 4 block, let me get that. So when we have 4 blocks, we are actually getting only 1 at the end. So the Voronoi does some stuff. Well, maybe it's out of scope here, but yeah. So it sample in some way to get only 1 out of the 4. So that's the general introduction of the biome stack and how it look in the code. It can be a bit much when you are not familiar with it, but I think understanding at least the diagram and how it works, like how there is one stack, then it's separated in 2, then it's merged again. I think that's to the level of everyone, and it should be understood by most of you. So now to the interesting stuff. We are going to visualize everything. So let me get mind map. Let me just remove the features and let's look a bit. So this is can we just, oh yeah, of course, restrict maximum zoom. Oh yeah, that's a bad idea. Yeah, I forgot about it. Yeah. So here it's the first layer. Of course, it's taking a while because we are at scale 4000. So remember, it's like 4000 by 4000 each square of it. So it's a lot of chunks to generate. And then, so yeah, maybe I should have restricted the zoom because. Okay. Great. Yeah. Okay, it works. Never mind. So that's the continent layer. So it makes huge blob, which are basically the lands, and a lot of ocean. The land are only 1 in 10 chance, so there is not a lot of lands. But if we go at the scaling layer, so here we are already seeing the pattern of the scaling layer, which is basically making sure that some land can propagate around one spot of land. So if we go and see the difference. So yeah, we had 1 block, and then when we go at the scaling layer, we have a lot of them which are land, but actually we missed a few in. Then there is a land layer which actually add more land, so it connects some land. Then there is again scaling, so it reduces the scale, and also yeah, it organizes a lot of stuff. Land layer again, it adds some land. So yeah, there is a lot of land layer because at the beginning there is a lot of ocean, and because ocean, when it was introduced in Minecraft and there was like endless ocean, it was not great for a player because you had to rely a lot on swimming or boats, so it wasn't really that fun. So yeah, then we had the ocean, the island, which is basically just adding more land, but it's adding land where there was not. So basically here there is only ocean, and if you scale, you can have ocean land here because it's not connected or anything. So by adding island, you are adding some land where there was none before. Then there is the cold, which is adding the forest and the mountain. There is again some land, so it's adding more land. Temperate, which is adding the cold, the hot biome. So here it will be a desert, and there will be also plain. Yeah, again. So it will be desert that will be added, and usually it doesn't affect mountain and forest. Then you go to cool layer, which is supposed to add taiga, I think. I don't recall exactly what is adding. Oh, I think it's adding more mountain because mountain can be derived in taiga. But basically here we have the 5 first ID. So ocean is 0, land is 1, then desert is 2, mountain is 3, forest is 4, and yeah, that's the first 5 ID. It's basically the start of Minecraft, because at the beginning there was only those biomes. Then we go to the special. So special is adding noise. In fact, it's adding new biome which are not gray biome. So it's number that are more than actually the 256, 55. Then after the special, we are scaling. So each time we are scaling, we actually go, we divide by 2 the scale. Then we are adding some land, and as you see, it's starting to become something. Then we are adding the mushroom, so basically we can add a spot of mushroom each next int 100 equal to 0, and we will see later how to actually shortcut that. Then we are adding the deep ocean, so the deep ocean can only be in ocean, and it's basically not at the coast, it's at the center of the ocean. So here we can see already that it's quite a good biome generation. Like, if I was to tell you that this is actually the map, and we say that each square is a chunk, I mean, you could play on that. It's not great, but it's not bad. I mean, it's possible to play on it. Then the interesting part, we are adding the new biomes. Well, biomes, all the biomes that were actually added afterwards. So we have the taiga, we have everything, and we see that there is a lot more color in now. We are adding, so yeah, since 1.14, where panda was added, yeah, when jungle was added, the panda were added. We have the bamboo jungle, which spawn in jungle, which were added. Then we are scaling again, and right now it looks more like a Minecraft generation, because it's at scale 64. Yeah, of course, the stream will be saved for, yeah. Is edge layer, so it's, if you look at a bit between the edge, yeah, maybe you can't see much, but it's basically refining the edge. So yeah, it's not really, but it can be seen here. Alright, just look at this spot. As you can see, it makes the edge more looking like it should be, like there is a gradient of temperature. Because here, for example, you are from ocean, you are going to taiga, and to giant tree taiga. You can't have just giant tree taiga just on the side. It makes no sense. Then we are using the noise layer, so that's actually what is used for the rivers and so on, and also for the biome. So yeah. Yeah, I didn't know that we could do that, but yeah, guess it's great. So that's used for the river. So yeah, but it's scaled to that point, and at that point, it basically what we are expecting to use for the river and the biome. And at this point, it's merged with the first stack, and it made the current map, which is actually playable, because right now there is enough biome to be well, playable. Then I'm guessing, yeah, it doesn't work every time, but yeah. We are adding the sunflower plane, so that's only in planes, doesn't really matter. We are scaling again. Then we are adding more land, because why not? I mean, I didn't design that, but actually the land layer could be a bit removed and simplify. Scaling again, so it's refining each time. Then there is the edge, so as you can see there is a delimitation, so the beach are made, the correct edge between biome are refined, each thing is done correctly. Then there is again scaling, and there is smoothing, which is done between biomes, so it looks a lot sharper, and yeah. So as you can see, we went from that to that. That's quite a difference. So now let's look at the river. So right now, yeah, if you didn't follow, what we did is actually that path. So we went that stack, then we went for biome here, then we did a little trip here and we saw the river initialization. Then we saw the merging of that and that in hills. Then we went here, and here we have the smooth scale, which is that one here, which is that. So that's actually the output that is with the biome and so on, but there is no river yet. So now we are adding the river. So we are again scaling the noise layer. So we are scaling a lot of it, and each time we are reducing the scale. And then we are converting it to river. So yeah, it's quite hard maybe to see it, but as you can see, there is currently some shape. And if you are looking a bit closer, so yeah, of course it's scaled, so yeah, but it's using the shape to make the river. And that's actually smooth scale, so it looks a lot sharper. And then it's merge. So the merging basically is simple. If it's on land, then yeah, maybe if we look at that part here, maybe I should put the cursor here. Yeah, so if it's on land, then it just added, so it's like a copy on. Then there is ocean temperature, so that's basically the pellet noise. We can recognize it with the weird shape, like it makes smooth shape and so on. But actually, it's quite poorly seeded because it's not making the good smooth shape we are use like in the Nether. In the Nether we have smooth shape and it looks a lot better. No, the end is a bit rough, but here, yeah, it's quite rugged. Then we are scaling that again we are scaling everything. We are refining the noise, scaling, and then we apply the new biome gradient to the full map. So if we back here, we had a cold biome, and if we apply it, we have also some cold biome here. And here we had scale 4, and if we apply Voronoi, then we get the final scale, which is 1. And basically, it's most the same. Some stuff are as well. The scale is not obviously the same, but most of the stuff are staying on the same place, just on the edge that are moving a bit. But yeah, basically there is not much change. Okay. So we saw about biome. Of course, yesterday we talked about features which are added afterwards and checked against biomes. But now we can actually look a bit at the code and we can actually understand a few things, because we saw that how Biome Generation was implemented, which is thanks to a QCG. Then the algorithm, which is actually stacking layers, and we'll see in the title what a layer is. Then we saw how actually it behaves in the game, so how it looks like. So now we need to see what a layer actually is. So if we go at the top, let me remind you what container layer does. So let's go here. Okay. So content layer is making ocean and plane. If we look, it's exactly that. So if next int is equal to 0, so 1 in 10, we have a plane. So here it's 1 in 10, else we have ocean. Then if we look at the second layer, so it's a scale layer, so it's a bit complex to understand. So maybe we'll go to the land layer. So the land layer, it takes, it's complex again. Yeah, I don't want this complex example. Island layer is easy. So basically, it takes the yeah, on one line is better. It takes the parent, so it samples the parent, so it implements a cross layer, which is actually getting the parent sample. So it's cross, because yeah, that's how it's sampling for that. Each layer sample in different way the parent. So because when you are moving from one layer, you're actually changing the scale. You actually need to sample around to make sure that you are not making some weird move. Like if you just sample one and like you decide from one, it makes no sense, because actually you will not have some contiguity in continuity in the noise, because actually what we are making is just a noise. It's a noise map, but it's quite elaborate, but it's still a noise map. And then, so we are sampling, we are making sure that it's a shallow ocean, so it's ocean. And if it's ocean and there is one chance in 2, then it's adding plane. So island layer is adding more planes. Else it's just giving the center, which in most cases is giving a biome, because another biome, well, it's always giving a biome, because a land biome, like forest, mountain, and so on, because else it will go here. So that's just adding more land in the ocean. And basically all the layers are like that, except some particular one, like the scaling layer, which is actually just sampling at different place and giving the result depending of the sampling. Then there is some interesting layer. So I talk about base biome, which is basically adding most of the biome. So there is the dry biome, the temperate biome, the cool biome, and snowy biome. So depending of the yeah, because I didn't go first on here, depending of the climate layer, so which type of biome we got, then we are actually getting some from, oh damn it, I lost it. It's base biome. We are getting some other biome, so from dry biome, so from desert, we are getting the desert, savanna, and so on. And as you can see, they want more desert because they gave it 3 out of 6, but less plain, and yeah. So that maybe is one of the crucial layer, because it adds a lot of biome. If you look back at how it actually looks, let's go before. So before it's quite bland, there is only 5, and at base biome it adds a lot of biome. So that's one of the crucial layer. Of course, the climate is also crucial, because the spatial gives the possibility to have new biomes, and yeah. So now let's go to the code. So just if you want to start up, maybe you should either use the seed repository or use that. So you add biometil and seedutil. And if you need to just sample some biome, you can use actually that overworld biome source and just give it the version, your seed, and just get the biome at X, Y, and Z, because actually it's not sampled yet in 3D, but I'm guessing maybe it will be later on. So yeah, here we are getting the X and Z, and we get the biome here. That's the general use. But actually what we are interested in is finding some seeds that, for example, give a mushroom layer, a mushroom biome at some place. And that's our last point, which is biome shortcut. So biome shortcut is quite interesting, because with that you can actually not check everything and just make a quick check that can be done in a few CPU operations and not initializing all the biome layer. So let's take a look at what it looks like. Of course, we are not using device because it's just for showcase here. So I'm defining the biome I want to look at. The biome is a mushroom field, and of course I'm iterating over 2 to the power of 64 because that's the whole range of the biome. Of course, it's not how we recommend it to do it, but it's how it could be done. So yeah, just to be checked. Okay. So what we are actually doing is we are setting a seed, which is actually the seed for the layer, and we are checking a condition. So here we are checking the condition that actually there is a mushroom that could spawn. But actually, to understand why that works, and maybe I should no, I will explain first why it works. We need to look at how it is seeded behind the scene. So if we go back to a biome layer, we can actually see that each biome layer has what we call a layer seed, which is given from the word seed and the salt. So salt is getting from the biome stack, so basically it's 1, 2000, 1. There is some that are similar, but most of the layer have different salt. And biome layer, maybe I should close everything because else biome, just give me 1. Okay, so we have a layer seed, which is basically using the 48-bit, the 64-bit QCG. So yeah, it's using the add-ons. Yeah, it's mimics. It's done by Knut, by the way. But yeah, so yeah, the mimics is that multiplayer and that add-on, but yeah, you don't care about that because it's internal details and usually you don't care about that. But it gets a layer seed, so it mixes the salt before, then it mix it with the again with it and so on till it gets some salt that is large enough, and then it mix it with the word seed. So if you have a salt that is 2, actually it's quite different than a salt which is 3 because there's a lot of mixing going on. So yeah, then it mixes with the word seed and it's mixed again. So yeah, the seed is getting a lot bigger than its modulo 64 bits, so yeah, it's going smaller and bigger and smaller and so on. Then there is actually another seed which is used in biome layer, and that's the local seed. The local seed is actually quite important because if you look at that, it's actually the seed which is used for all next int operation. So let's take a look at the mushroom layer. So mushroom layer, it's inland, and so it's sample, and it check that around there is actually one shallow ocean. No, it's for all. So there is shallow ocean in center, in the southeast, northeast, and northwest. So it's a X cross layer, and then it check also that the next int 10 is equal to 0. But what is actually the LCG behind that is actually the local seed, which is actually just shifted by 24, and there is a floor mode, so it's quite weird actually. But yeah, and that's mixed again afterwards, so the seed is updated. But actually, because for each layer it's initialized with the word seed, the salt, and the parent, we can say that actually each layer is decorrelated with from the coordinate. So each layer is decorrelated from other layer in the stack, and also on the coordinates. So you can set a seed. which depend of the word seed, the X, the Z, and the salt. And that's quite important because if you have layer 1 at the same X and Z, layer 2 actually has a salt which is different. So this seed, so layer 1 dot seed is actually different than layer 2 dot seed. And that's quite important because if we want to check nexting, because remember each time a layer is used for a specific coordinate and specific word seed and specific salt, then it's set with that value, so the seed, which is using the mimics, then that value is used to get the nexting, so it's just modulo shifted by 24 and then it's floor mode. So if that's true, then actually that result is also true. Mostly, yeah, it's not exactly, but it will hold for a lot of cases because the mimics will have a higher entropy in the I bit. And because that's true, we can actually shortcut. And yeah, I went too far for this one, but yeah. So why can we shortcut? It's because we are sure that the local seed we are getting from a specific layer, a specific position, a specific seed, is actually different than any other layer in that specific seed and any other position, because the positions are also mixed inside the local seed. So if we check that, we are actually making the assumption, which is actually true, but for this seed, this position, and this salt, we are sure that this will not produce a nexting 100, and will actually not influence overlayer. Actually, it can influence overlayer in part if that it's multiple of another layer, or if the salt is too small or too close to another one. But yeah, most of the time it will not influence overlayer, so you can actually discriminate just from that. So to get the local seed, usually you get the layer seed. So the layer seed is getting from the seed and salt. Just a quick reminder, it's set for each layer. And there is a local seed which is set through the X and Z. And that's actually also using the mimics, and it's mixing X, Z, X, Z. It's quite a common pattern in Mojang code. So now that we have, so why it works in the big lines, actually we will try that. So that's just debug because I want to showcase something else later. But if we are checking that at 0, 0 we want a mushroom island, actually, as you can see, we are continuing if we are having a bad one. So if we are not having a next in the 100, we are continuing, and we are displaying only the seed that will have a mushroom. So if we run that, of course it's building because it takes time, and we are already done. And remember, because we are continuing, we are not checking the full biome. Here when we are doing get biome, we are checking the full biome, so we are building the, well, not exactly building, but yeah, building in part the biome stack, and also initializing every layer and sampling everything. But because we are not doing that for every single seed, so for which is 150k, we actually can do it in about 2 seconds. Yeah, well, yeah, I mean, we can do it really fast. And that's all the seeds that have a mushroom layer at 0, 0. So we can try that. I just took a random one here. Let's try that one. We go here, we do that, and we start. And as you can see, there is a mushroom layer. A mushroom island. And that's actually true for all the seeds. And that's how we can shortcut a lot of stuff. Because, yeah, we actually don't need to check the whole stack we only need because we have almost this inequality for most of the seed. We can set that for a given x, z, and salt, we can check that the seed match some condition. And the condition here is actually that next int 100 is equal to 0. This project is actually Biome on. It's actually on GitHub already. I mean, it's not my code. All like some part are my code, but if you go to Captain Wutax, maybe I should. You are not known enough, Captain Wutax. Seriously, the fuck. Okay, go to GitHub and yeah. So, biometals, that's it. That's biometal. Yeah, I contributed some stuff. So yeah, that's basically to check biome. And my map is here. Say it's amiss but in better. And basically it's it's that. But you actually need to use well, I can provide a jar if you want, but it's better to just run it from the IDE for now. It's not stable enough, I think. So I don't know. Maybe ask Cap. Anyway, so we are now shortcutting for mushroom, but now we want actually to do some smarter stuff, and that's where Azeroth. I don't know if you are still there. I'm not sure if you're still there. Maybe I will ping you, because that's an interesting part for you. Because now I have covered everything, so.
Yeah, I am.
Ah, okay.
Looking at it.
Yeah, sure. So yeah, if you want to talk, you can. I mean, you can ask a question. So now we are looking for some other challenge, which is to find. Let me find it. Dark forest. So dark forest actually is quite a hard one because it depends of a lot of stuff. So the first thing you need to know is that in the Paz biome there is most of the stuff you need because that's where the stuff are. And if you look, dark forest is in temperate biome. So to get a lot of dark forest, you can actually just make sure that this base layer biome is given in the next roll of 6, 1. So that's easy actually to check. So let's say that we want to check for the center. So let me comment some stuff here because I will explain them later on. Let me just run it first to show you the results because it's actually pretty good. So we get 28% of dark forest compared to the standard probability, which is less than 0.3%. So like, yeah, no, it's less than 0.003%. So like it's bonkers, and that's only on a few on the few first. Like it's on the few 1,500,000. Yeah, 500,000. So 28% we get with the shortcut, and yeah, that's a lot compared to what we will get if we did all the seed. Yeah, so 28% compared to that is actually the speed we are getting. So we are getting, let me get a calculator. 28 divided by 0.003. We are getting a 9,000 boost in speed, which is actually huge. But anyway, so the first thing, yeah, we can do is actually to make sure that we have the dark forest roll on the center. So yeah, I will explain later what I mean by the center and outer. So if we say that in base biome we have modulo next in 6 is equal to 1, then we actually get a lot of dark forest compared to not having them. Of course, yeah, it will print. Maybe I should reduce that number for now, because else it will be just a nightmare. Because next in 6 is not a strong requirement for now, so it's not enough to say. So yeah, actually we have 16% compared to 2%. So we are getting 8 times more. We are 8 times faster than just checking all the seeds, which is great because that's just checking next in 6 and we get 8 time boost. But actually we can do a lot more, because in the base biome layer, to get the temperate biome, we actually need to have a desert already. And to get a desert, if I get my Excel, we actually need some pretty stuff. So let me maybe remove that part, because that part is false. Yeah. To get a desert, we actually need something which is looking like that. We need a plane at the middle. Then we need either of the cardinal direction, which is a forest, or a mountain. And that's actually pretty, well, that's needed because of the layer which is called, just make sure that called, yeah, it's in the climate layer. So if we go in the climate layer, temperature, climate, we look for desert. Here. So in the temperate, we need, yeah, I reverted. So we need center is biome plane, and we need one of the direction, which is either mountain or forest. One of them will be enough. So basically having this requirement give us a lot of desert. Desert at that branch doesn't give a lot of desert overall, because actually if you want desert you want to go in the dry biome. But you will get a lot of temperate biome, because you will go in that branch a lot more. And that actually you can see it. So if I go back to my test, and actually I increase the plane at the center, so that increases the plane at the center because we are looking for a continent layer and we are making sure that it's not ocean. Then we are sure that the cold layer give us plane, because cold can also give us forest or mountain, so we are making sure that it gives us plane, so it's superior to 1. And then we are making that on the outer layer there is actually not plane, so it should be a mountain or forest, and that we can also see in the code layer. So if we go in the climate code, you can see that here, if if the next in 6 is equal to 0, then we get forest, 1 mountain, so it's negative, inferior or equal to 1 to get forest or mountain. Else, if it's superior to 1, then we get plain. So basically we are excluding on the center the forest and the mountain, so we are checking that it's superior to 1. And in the outer layer, so again that part, we are checking that we get a cold forest or and also no, not a cold forest, a forest and a mountain. And basically by just doing that, we are actually getting 31% more dark forest, which is better than than what I gave you. But actually it's because you can I cut. Actually there is one more stuff we can remove, and which is jungle. So yeah, currently we are getting more speed than with 28%, but it's currently not that good because we are getting a lot of jungle. and that's because in the base biome, so if we go to base biome here, if we go in the temperate here, so deserts, then we get, if the special bits are superior to 0, then we get jungle, else we get the roll, and we constrain the roll to be next int 6 equal to 1, just to be sure to have dark forest always. So we actually can target the special layer, and we can make sure that actually it will never influence the higher bits, and we will make sure that it will always go in that condition. So if we do that, then up, and we go here, we actually see that we have 0% of jungle, and we have the branch 2, which is it 50% of the time. Of course, we can't not cut the branch 3 and 4 because actually it goes in different directions for the branching. But actually, we have most of the call which are done in the branch 2, and we are getting speed up, which is about 33% out of, it's faster, because I'm actually on smaller seed. If I am adding that, we get 28%. But yeah. So basically, just by doing that, we are making sure that we we are getting a lot of dark forest, and at relative cost, because actually it's just a few lines, and it's But that's only on the. So maybe I showcase. So I take one seed. If I go new from seed, continue. Yeah, it's a dark forest. It's not a huge one. And so to increase actually the dark forest, you need to do something which is a pattern. And to choose a pattern. So now I need that. You need actually to do some pattern like that. Because remember, you need one of the cardinal direction to be either forest or mountain. So you can actually get dark forest in that pattern, or you could get it in a pattern like so. And because there is actually some smoothing going on, and there is a scaling and so on, by doing so you can actually make sure that you get a large enough dark forest that it looks that it's contiguous. So right now I'm just checking for 1, so 0, 0, I'm checking that around, so I'm checking the cross here. But actually I could just check 0, 0 and check that above there is a forest and mountain, and that's enough also. So like if I remove that, I get also more speed because, and I'm also getting dark forest. And actually I'm getting more because I'm less constraining the stuff. But yeah, anyway. That was, for the dark forest. It's quite complex because actually it involves multiple steps. But basically when you are doing biome shortcut is what you are looking for. Because you know that you want to target some layer. So you know you want to go in that case. And you know you want a special bit, so you actually need to use the special trick, and then you need that next in 3 is equal to 0. So if it doesn't equal to 0, then you skip that layer, and that's possible only because there is actually some kind of unicity in the set. But yeah, what I'm talking here are actually the slow way, like here in my test I'm just iterating over all the seed space. Sure, it's fast, like it can do million in billion in a few minutes, and that's fast for some people. But actually if you want to go through all the seed space, which is, remember, a lot, like it's 18 quadrillion or something like that, or quintillion, 18 quintillion. So yeah, it's a lot. Then you actually don't want to do that. You want to actually to do some lifting, because as I said, each layer seed is actually a bit different. Then you can actually do some math. Well, it's not math, but yeah, it's math, but yeah, just linear stuff on it, and you can actually lift so you get the biome at some place. Because, as I said in my drawing, I don't know if I have still, in my first drawing, if you are influencing some layer, most of the time it's kept in all the stack till the end. So if you are maybe adding more mushroom island here, then actually it will be kept till the end. So that's actually quite good that it works like that, because it makes our job a bit easier. So there is something called the biome device, which is here, and you can basically add some restrictions. So some of them are here, but not all of them. Like right now there is the continent one, the island one, the cold forest, cold mountain, cold plain, special, mushroom, sunflower plain, bamboo jungle, but actually you can make them for most of the biome, and it's quite easy enough to be done. So yeah, except some weird case like dark forest is actually quite hard because it depends on so many stuff. But if you are only wanting dark forest most of the time, you can just check for that, and that's an easy check. But actually, if you want to have only dark forest and like all the time, then you actually need to check a lot of stuff around, because that's important stuff. But yeah, I think I cover everything. I'm guessing not many people have question. I monitor the chat, but there is not many question. Sure, yeah. I mean, it's a hard topic. It's not something that anybody can understand easily, because yeah, it takes time. I'm trying to make it, don't know, layman enough. Like it should be understood by most of them, most of you. But it's still something that yeah needs to be explained, and yeah, it might not be as easy as it looks. Anyway, I think I've done everything I wanted to do today. Guessing tomorrow will be about turn noise, which is again some fancy subject, and that's actually more complex than just biome. And yeah, so if you want to get the tools, of course, you can go to Captain Wutak's repo. So biome utils for to get the biome code. Simple example with biome device. Yeah, sure, I can do a simple example with biome device. I just need to start the main. So this biome device is basically doing that. Is basically doing what my test is doing, except it's doing it more a bit, well, with a lot of sugar syntaxic and some more stuff behind. But yeah. So if we want, for example, here, well, to have a color restriction, yeah, it may be not the smartest one. Let's set a mushroom one. So let's just start with a simple one. Let's start at 0, 0. That's all you need actually to do with the biome device to get it working. Like, and yeah, you get most of the seed out. So if I take one random seed and I just go here, new seed, continue, yeah, I get a mushroom island. Of course, it's a small one, because if you go in the setting and you go at mushroom, yeah, it's here, you get 1 square. If you want actually more square, then you actually need a for loop and check for different so yeah, here device add restriction, so mushroom yeah, restriction mushroom and XY. Let's just take a 2 by 2. Of course the seed will be quite high, because yeah, there is no lower seed that can produce that, but yeah, it should work. So right now we are lifting. So lifting is basically just trying some, making sure that the lower bit are matching, and then we are iterating over the higher bit. And as you can see, yeah, basically yes. But you need to make sure that the restrictions are not incompatible with each other. So you are making restriction, you are making sure that at the chunk 0, 0 at layer, so that's layer 260, there will be, so if I show you layer 260, 255, 56, you see there is a 4 of 2 by 2, so 4 blocks. But actually you could maybe say that, but you can say at scale layer, sunflower plane, you get something else. No, you can actually do it directly. So let's add that sunflower planes up. Let's add the sunflower plane. So right now, what I'm checking, I need to illustrate it because else you will not understand what I'm checking actually. Control N, don't save. I'm checking that at layer 256, we are having, you get that? No, I don't want that. No, don't want that. Bear with me 1 second because, yeah. Okay, we are checking with edit color. We'll get a better blue, better purple. Okay. We are checking that we have mushroom. Then we are checking that sunflower plane, so it's layer 64. We'll actually get at 0202, so layer 64 is actually 4 times smaller. So maybe I should change color. So yeah. Okay. 4 times charm. Okay. Yeah. I need to have some tool to do that because it's so tedious to do it like that. Okay. And now I'm checking that there is sunflower plane here. So you actually need to be aware that there is a difference between the layer in scale, but you can actually combine them. So here I'm combining both of them, and if we do that, might not yield some result because it's quite a bit of requirement here. So we got one, but maybe it's not in the 38. Yeah, there's a lot of bits, so it might take a while. Yeah, sunflower plane is quite hard to. Is there another bound restriction which is available, which is easy to do? No, that one. Yeah, I would need to add something like for the ocean. Maybe it would be easier. Let's just add one which is 0, because it might be easier here to do it. Of course, because it's a mushroom island, then it needs to have yeah, that's hard to get. Let's just add it under the. Again, you need to make sure that they are not incompatible because mushroom island means that actually you will get water around. So to get a sunflower plane, you need actually an island. So here I'm checking that there is an island here to get it. Yeah, but bamboo jungle is not actually. Yeah, bamboo jungle is not actually on what I want as a layer. I wanted to show the difference in between. But yeah. Yeah, most of them are incompatible. So usually you want them to be offset by enough so they are not putting each other on. So But of course, that's the beginning of the stuff, and it will be shortly better in the future. So yeah, yeah. Did you actually do it correctly for Bamboo Jungle? Yeah. Oh no. Yeah, okay, you are doing the smallest check. Yeah. Yeah, those restrictions are actually not that complete. In my test, like I show, you can actually do a lot more restriction to actually find them quite easily. But yeah, composing them is quite hard. Like, actually, yeah. Maybe let's. It will take forever, I guess. Oh, damn it. Yeah. Maybe let's just look for that. And it's easier. Yeah, it will be taking forever. Yeah, everything that is above 32 bits usually in biomes, like lifting more than 32 bits is huge. Like it will take forever because biome, like I said, is so slow. Yeah. Okay, yeah, I'm guessing it will not finish, so don't care. Well, it will finish, but not yet, and I'm not. I don't want to wait for the next. Yeah, go to 2 because of that. Place it working. Okay. I think, yeah, there is actually a repo that does it quite fast. I think it's Techman. Let me find the repo. Maybe it's in the Discord, I think. Oh yeah, 3 by 2, yeah, it should work. But I mean, just adding 2 more. Yeah, but anyway, yeah, I think you get the idea, which is, yeah, lifting is way more powerful than iterating. But of course, behind it, it's the same streak. It's just checking that because we have the almost unicity, but a layer seed is different for a layer X and Z and salt and the world seed, then we actually can make sure that we differentiate each layer and make a check on it. Well, some people like to visualize. That's why Captain Wutax made this mode. So you can actually do it by just looking at the code. Like usually I do it by looking at the code because it's easier and usually you get a better understanding of what to do. Like for the Dark Forest, there is actually a few steps and it's just visualizing it is not enough. So usually you want to try and actually report statistics. So for my measure shortcut, I'm using a lot of stats. So I'm adding a lot of counter and stuff like that to be sure that I'm counting everything right. And yeah, but for you, for the end user, you just need to know that biome shortcut exists. And actually, the biome device will be the main product we will be putting out. Not the product is something, the main code that will be available. And with this API, you could find biomes which have requirement. So, like, you could find, let's say, a mushroom island here, then mesa here, then a jungle here. Okay, yeah, it's already here, but an ice spike here, maybe a savanna here, and here you want a dark forest. Yeah, you can get that. You just need to specify that at this corner, this corner, this corner, this corner, and at the center you want the mushroom island. That will be the end goal. It's not completely finished, but it's in progress, and again, yeah. It's quite fast enough. Like, doing that is actually, if you wanted to do it iteratively, it will take years. Like, right now we are doing it the smart way. Well, Cap is doing it the smart way. Anyway, I think I cover everything. I know it was quite fast, maybe for some of you, maybe quite slow for some of you. And maybe it was not good English, but yeah, remember I'm not an English speaker, so yeah. I'm trying to have everything compact and neat, so yeah. I'm guessing it will be the end of the stream if you don't have any question yet. And tomorrow, same hour, we'll be talking about terror noise. And again, it's a difficult topic. But once it's covered, then we will be able to talk about some other stuff. And that will be the interesting part, I guess. So thanks for tuning in, and I hope to see you tomorrow, same hour. See ya!